Hey everyone, we're back with our 9th webinar in our virtual classroom series. We've talked in the past about performance stability in your upgrade projects, but today we're going to take it a step further because while performance testing is certainly a big part of performance stability, today we're going to show you how to use the cloud to perform your performance testing.
We know it can be a struggle to find proper test hardware. You might miss a license or find yourself short of spare hardware. Or it might be that your test hardware is that mainframe that sits all the way back at the end of the server room, all covered in dust.
Hey, Daniel. I mean, you're the youngest in the team, right? So look, I've got a broom for you, so you can go to the server room and clean up all the dust. Of course, we're just kidding here. But we will show you how you lift your database to the cloud and use then all the performance testing methods. And then bring back the results. That's the important part. So enjoy. So let me start with the introductions today. This is Roy Swanger. Roy is the Vice President for Database Upgrades, Utilities and Patching in Oracle. And that includes tools such as Data Pump, SQL Loader, but also Data Patch. Roy is based on the East Coast of the United States, approximately an hour by car north of Boston. And besides being a big Boston Red Sox fan, he loves also watching games of his favorite football club, Liverpool FC. Please follow Roy on Twitter. Roy F. Swanger is his Twitter handle. And I can tell you, Roy uses Twitter only for technical topics.
And here we have Mike. Mike is our distinguished product manager for database upgrade and migrations. When he's not out hiking in the Alps, he is probably sitting somewhere solving a complex upgrade or migration issue. Whatever comes out of that troubleshooting usually ends up on his blog on miked3de.com, which is why I highly encourage you to pay it a visit and put it on top of your blog roll. You can also follow him safely on social media. He only writes about tech, and so far I haven't seen him post a cat nor a puppy video.
And because you just heard Daniel introducing Mike, let me introduce Daniel. Daniel is our Senior Principal Product Manager focused on cloud migrations, and he has a very strong background as a production DBA. He's based in Denmark, and if you follow him on social media or on his blog, you'll find that he does a great job of giving you step-by-step instructions and really usable information. So make sure you add him to your social media contacts. Let's start by talking about some of the common challenges that we see in performance testing projects. We've seen all of these at various customers. The cases where you have only a small subset of the production data, or even worse, have to artificially create a data set that looks nothing like your actual production system and therefore gives you very different optimizer plans. Tests done on inadequate hardware or manually, where it's more time consuming and more error prone to do your testing by hand than it is with automated tools. Or even cases where the statistics are fully out of date, stale, non-existent, or locked. And all of that will give you bad test results. And by bad, I mean inaccurate. Because what we've seen is when we analyze our service requests with our support team, and we do this about every 2 years, we go in and do root cause analysis. And what we have found consistently is that in the upgrade area, about 95% of service requests are actually not about the upgrade. They're about post-upgrade performance. In other words, they're the type of service request that could have been prevented by having robust and accurate testing as part of the upgrade project. On the other hand, we do run into customers who try to test too much. And you have to remember that testing, like so many things in IT, follows that Pareto principle, where getting the first 80% done takes about 1/5 of the effort, and the other 20% takes another 4/5 of the effort. You have to cut your testing off at some point, because otherwise you're going to blow out your project timescale, you're going to cost your organization a lot more money, and really it's not good for employee morale to be trying to get to that 100% test coverage. But what if you have some problems like you have old hardware that can't possibly reproduce your production workload or even hold your production database? I don't like having to go try to acquire hardware through our procurement process, and I'm sure you don't either. It's time consuming, there's a lot of bureaucracy involved, and you may not even have the budget to do it. Similarly, what about testing tools? We all know that we want to have automated testing tools, but most of those are not given away for free. So you have to go acquire those, get them licensed, maybe have them vetted by your security review group or whichever approval processes are in your organization. So how do we deal with that? How do we get to that step 4 in a successful database upgrade or migration, which is the performance stability after the upgrade? This is the challenge that we're going to set you up for first and show you how to solve by moving your performance testing to the cloud.
So you decided to do some testing. Let's go find some hardware. In OCI, we have plenty of hardware ready, just sitting there for you to use them. There are many advantages of doing testing in the cloud. You can provision instances as you want. You can get rid of them when you're done with your test, and you only pay for what you use. But did you also know that in OCI, with some of the database cloud offerings, in the license is included some of the options and packs that you have to pay for your on-prem systems? Have a look at this matrix. As you can see, the diagnostics and tuning pack is included in the database cloud services from Enterprise Edition and onwards. I know those 2 packs are very popular with many of you out there. The same applies with real application testing, which includes SQL Performance Analyzer. We'll have a look at that later on in this webinar. And also included in the high performance and up is advanced compression. Which use cases are there that can utilize these options and packs when it comes to testing? If you look at the diagnostics pack, the AWR and ASH is something that comes to my mind immediately. If you can run a realistic workload on your cloud instance in OCI, you can use those tools to quickly navigate into the workload and see where the bottlenecks are. Once you have identified a few problematic queries, or hopefully there are only few, but there could be tons, you can use the tuning pack to use the SQL Access Advisor and the SQL Tuning Advisor to get some recommendations on what you can do with those queries to make them run faster. Do you need another index? Do you need partitioning or something else that the advisors can come up with? Once you have identified some good changes to make, you can use SQL profiles to nail down those good plans. Also, real application testing is really useful, and especially SQL Performance Analyzer. You can have your workload represented in SQL tuning sets. You can then run it through multiple test executions where you change init order parameters, statistics, and so forth. And you can then do continuous improvement on your database configuration to find the optimal setting for your queries. In OCI, multi-tenant is the default. When you provision new systems, it'll come with pre-created container databases. When you use the console, the web page, to provision a new database, it'll be a container database. We all know the multi-tenant is the future, and eventually you will have to migrate into the new architecture. But I fully understand that you're simply not there yet, that you want to do testing on your non-CDB databases. You can still do that in OCI. You just need to know the little tips and tricks so you can create non-CDB databases in OCI. Virtual machines are the entry-level offering in OCI. There are a few restrictions that you should be aware of. For instance, you can only install one Oracle Home, which is the one that comes pre-created with the system, unless you do a database upgrade, but that's something different in this sense. You should also be aware that there is a maximum storage cap of 40 terabytes on virtual machines. So if you have a 60 terabyte production database, you can't do good testing on VMDB systems. If you want to create a non-CDB database, you should either migrate your non-CDB database from on-prem to the cloud, for instance, using ZDM, or you should restore a non-CDB database on top of the pre-created container database that you get when you provision the virtual machine. If you use the latter approach, you have to ensure that the DB name and the DB unique name exactly matches that of the container database that was pre-created with the virtual machine. Next, we have bare metal, which is the mid-level offering in OCI. You can create as many databases as you want. You can provision your own Oracle homes, and they can be of different versions. However, all the Oracle homes must be of the same edition. So if you decide to go with Enterprise Edition, all the databases on that bare metal system will be Enterprise Edition. There is a storage cap on bare metal system, which is 16 terabyte. If your database is bigger, you can't use bare metal machines. The bare metal machines comes with 51 terabytes of NVMe storage directly attached to the system, but because of mirroring and room for the recovery area, you only have 16 terabytes for your user data. You cannot use the OCI console, the web page, to create a non-CDB database. So if you need such, you have to use the DB CLI tooling. You log on as root to the system and execute it. When you do that, it's the command line parameter called no-cdb, which is the important one. This tells the tooling that you want a non-CDB container database. When you do that, you get a job ID, and you can then use the DB CLI describe job commands to follow the creation of the database. The last option is Exadata. Exadata is the world's best database machine. And if you have really large databases, you can put them on Exadata. On Exadata, the current storage limitation is 598 terabyte. That is what you get with an X8M full rack machine. If you only have a quarter rack, you have less storage, but the really big databases should fit onto an Exadata. If you need to create a non-CDB database on Exadata, that's currently only supported on 12.102 and 19C. If you want to do that, you have to use the utility called dbas API, and there's a reference to a Moz node which has really good and step-by-step instructions on how to create a non-CDB database on Exadata.
Time for challenge number 2, tools. Do you remember? A few weeks ago, we had an almost 2-hour seminar about performance stability tips and tricks and underscores, and you still can access this seminar on the Upgrade blog under videos. In this seminar, we showed you our performance stability prescription. And it starts with collecting plans on source, comparing with AWR diff reports, analyzing the situation with SQL Performance Analyzer, then tuning with SQL Tuning Advisor, manage and nail down the plans, if possible, with SQL Plan Management, and then test evaluate at the end with Database Replay. Now we transfer this for our today's session, because today we would like to show you how you interact when you have on-prem environments and when you use a cloud deployment as the test environment. So we start again with collecting the plans, but now we need to transport them. So we need to transport the plans into the cloud environment. Then there we can compare, we discuss later if that makes sense, but it makes a lot of sense to start the analyze process and tune and manage our plans. But when we are done, we need to bring back our results to our on-prem environment. So transport at the end is very important. And this is what we would like to show you today. And for this, we have a toolbox. We have a lot of tools, and we will use today, of course, AWR. We will use the cursor cache. We will utilize SQL tuning sets, and we will use staging tables to transport whatever. Then SQL Plan Management, SQL Tuning Advisor, and SQL Performance Analyzer are our main tools to ensure plan stability and evaluate performance. And we may also try database capture and replay.
Now that Daniel and Mike have told you about the hardware, the testing tools that are available in the cloud, you might find it appealing, but then be wondering, well, how do you get your database to the cloud in order to perform that testing? Well, that's what we're going to talk about here. And it is something that we've talked about in the past. We have a webinar, Move to the Cloud, Not Only for Techies, that Mike and Daniel recorded several months ago. And it's a really useful webinar. It's available on Daniel's blog. That was about production migration. And there are a few differences between migrating a production database and migrating a test database. One of the biggest differences is that when you're migrating a test database, downtime isn't really so much of a consideration. It doesn't really matter if it takes all day to migrate that database because your production system is still running. Also, you don't want to disturb the production system to perform the migration for test purposes. So if you're lucky enough to be able to use a copy of your production database in the cloud for testing, you want to make sure that getting that copy doesn't impede your production workload. The other factor about testing is that it's the type of thing you will do over and over again. You might have that classic 3 tiers of testing where you go in dev, QA, and then UAT type of testing. And for each of those, you might want a different copy of your database. So in order for it to be repeatable, we want it to be as simple as possible. It's not like a production migration where you're tolerant of a bit of extra complexity in order to minimize the downtime. So how do we do this? Well, the best tool is probably Data Pump for most cases. If you don't want to interfere with your production system when you're doing a data pump export, it's a good idea to migrate during off-peak hours to perform that export when the production load is not at its heaviest. Because while it won't interfere with your production workload from a functional standpoint, of course, a data pump export will use CPU, it'll use memory. So you want to make sure that that system resources are available for it. When you're migrating from a production system that's active in any way, then you need to set the flashback time or flashback SCN parameter to get a completely consistent export from the first table that's exported to the last. So that's going to be very important as well. Another way to decrease the time needed to migrate to the cloud is to use data pump compression on your dump files. That requires the advanced compression option, and it can give you a really good compression ratio and decrease that amount of network transfer time. If you don't have the advanced compression option, I'll suggest that you look into ZDM, Oracle Zero Downtime Migration. That's a utility that uses compression under the covers, and because we're providing that for you, when you're using ZDM, you don't actually need the compression option. If you're 24/7 and you really don't have that off-peak time available to perform the data pump export, another approach would be to use your standby database. If you have DataGuard configured, we can't actually export from a physical standby, which is a read-only database, because data pump has to create a table to keep track of all the items that it's going to export. But we can export from a snapshot standby, and we'll talk about how to do that in a little bit of detail here. That allows you also to coordinate with database replay by exporting as of a specific SCN and having your database capture from real application testing start at that SCN. We can get a really good start point for both our replay and our export. So let's talk about migrating from a specific SCN or system change number. The reason we would want to export from a standby database is both to offload the load from your production system, you're exporting from a standby, but also to avoid that old snapshot segment too old error. Now, the reason for that error is that when we are performing a consistent export, and you set flashback time or flashback SCN parameters, we have to accumulate undo for the entire duration of the export in order to export as of that specific set of time, because there's other activity going on in the database. So if you have a very large database that could take a few hours to export, that means accumulating undo at a very high transaction rate for those many hours. And if you don't have enough undo retention, that's when the ORA 1555 error comes in. Well, exporting from your standby databases solves all of those issues there. What we could do is we stop our redo apply on the standby database and convert it to a snapshot standby. And then what we can do is we can recover to a specific SCN. And what we would do in that case is coordinate that with the time, if you're using real application testing, that you start your database capture. And that way our database capture on our primary system is coordinated with the point at which we're exporting from our standby. Then we convert to the snapshot standby, and this means it's open read-write at that specific SCN, but nobody's using it. So because nobody is using this database, we don't have to worry about flashback time or flashback SCN. We can just do an export. The database is fully quiesced. We're the only user there. We don't have to worry about people changing tables out from under us. Perform our export, and then we convert back to a physical standby, and it will catch up. So this makes DataGuard and Snapshot Standby a terrific tool for doing your testing and migrating from that standby for testing purposes. You could also migrate using existing backups. You could have a copy of your database that is already been backed up using RMAN. Now, again, if your backup set wasn't originally compressed, you might want to just compress the files at the operating system level before upgrading them. Again, using the existing backup has no effect on the production database, and it does have the bonus of letting you test that you know how to recover and restore that database, how long it's going to take, because it's usually a good idea to know how long it will take to restore and recover your production system. I guarantee if you ever have to restore and recover your production system, somebody several pay grades higher than you is going to be looking over your shoulder asking how long it's going to take. So knowing that in advance is a good idea. And it's also useful because then you'll know whether you could use the cloud as a disaster recovery strategy. The nice thing about the cloud is that you don't have to pay for the hardware until you need it. So in a disaster recovery terms, having that kind of strategy tested and in place is really useful because it's the type of thing that doesn't really cost you anything. It's not like having a whole separate DR system at another site that's there just in case. You have it there just in case, but really the cost is absolutely minimal. Now, a couple of things about uploading those files. I mentioned that uploading the dump files is going to be one of the longer parts of your migration process. There are ways to make it shorter and make it more robust. The first is that you should use multi-part uploads for any files that are really larger than about 100 megabytes. We know that the internet gremlins can intrude into files and tweak a bit or a byte here or there, corrupt a dump file. So to avoid that, or to make it easier to recover if you do have something that gets corrupted by the network copy, breaking the files up into smaller chunks just makes all of that easier. So you can use the OCI command line interface utility. You can see the link in the slides to the installation guide for that, and it gives you the APIs or the commands to be able to upload files in multiple parts. In addition, it gives you the ability to upload many files at once with one command. So that will do a multi-part upload and a parallel upload together. And that means with one command, you can upload lots and lots of very big files and not worry about what happens if one of them or another somehow goes awry during that process. You can recover from that pretty easily. Couple of options there. One is that you could limit the parallel upload count or the part size if you want to. You might need to do this depending on your network traffic, maybe throttle it during the day and have it bigger at night. You might want to prefix the file names because when you're going into an object store bucket, these buckets can be arbitrarily large and you may not know exactly what else is in there or who else is using that bucket. So having the files prefixed with something identifiable to you will make it that much easier later. And then you can include or exclude files selectively. So let's say you do your bulk upload and then you find that you have one or two files that need to be re-uploaded. You can do that pretty easily as well.
Thanks, Roy. Let's talk a little about upgrading in the cloud. Potentially, the change that you are testing involves a database upgrade. So how can you actually upgrade the database in the cloud? What makes sense to you? Basically, there are a few methods that you can use to upgrade the database. The first one is to use the cloud tooling. This is the tooling that is provided in the OCI console. It's simple to upgrade the databases that way because it is a one button or two or three button approach, and a lot of the stuff then happens behind your back underneath the hood. but it requires a fully supported and working database cloud services. If you have migrated your test database onto for instance, a VMDB system, you might accidentally break some of the cloud tooling, and then you can't use the inbuilt cloud tooling to do the upgrade. Also, the cloud tooling is slightly slower than doing the upgrade yourself, but the main reason for not using the cloud tooling, I would say, is that you cannot use the cloud tooling for the real production upgrade that you have to do eventually. One of the good things about testing in the cloud is that you can also test the upgrade procedure of your production database. But if you use the cloud tooling for that, you get no practice in the method that you will use for your on-prem database. In that sense, it is much better to use auto upgrade. If you upgrade, for instance, a VMDB system with auto upgrade, you will break the cloud tooling. But to you, many of you, auto upgrade is already a very familiar option, and it is very likely the option that you will use to upgrade your on-prem production database. So by doing that in the cloud as well, by using auto upgrade in the cloud, you get practice in upgrading that database. The last option is to use data pump and then migrate directly into the new release. You can use the full features, the powerful features of data pump, but most likely this is not something that you will do for your production upgrade. So again, I would prefer not to use this method unless I really have to. We also saw this slide earlier today, and let me highlight some of the challenges that we do see. That you're only testing on a fraction of the data, or you use artificially created data sets. Our clear recommendation is to bring all your data to the cloud. But when you do that, you should again be aware of the storage limitation that comes with the various cloud offerings. Again, here as an example, a 60 terabyte production database will only fit on an XRCS. There are a few options that you can use when you migrate your database to the cloud. You can either take all of your data, the entire database, structure and data, or you can migrate the structure only. The good thing about bringing your entire database is that it allows for full testing, including application testing. You can connect your application to the cloud database and do some very useful end user testing there. But if you only migrate the structure, it doesn't really make sense to connect an application because there is no data there. But obviously, when you bring an entire database, you will use more resources and it is more costly. But bringing all the data is really our preferred method. But if you don't have the resources for that, or if you have a really large database, you might decide to migrate the structure only. If that is your choice, you can use data pump to export only the structure of the database by using the content equals metadata only. This will extract the definition of the users, the tables, the indexes, and so forth, all the metadata, but it will skip all the rows of all the tables. When you then import the data into the cloud database, you will have a complete copy of your database, of your data, except all the rows are missing. But the good thing is that the statistics in the cloud database will still reflect that of the on-prem database. So imagine you had a customers table with 1,000 rows. In your cloud database, after the import, even though the table is empty, the customers table is empty, the statistics will still say that there is 1,000 rows in there. And the statistics are locked to ensure that those representative statistics are not overridden by, for instance, the automatic statistics gathering job. Another option is to truncate the tables before you do the export or before you migrate the database. You have to truncate all the tables in one table space in order to shrink or resize the data files down to a minimum size. So if you have a 10 terabyte table space and you truncate all the tables in there, you can use the alter database resize command to shrink that data file, those data files down to a very little size. And then you can easily migrate a 10 or 20 terabyte database into the cloud. But be aware, when you truncate a table, you're also resetting the statistics on the database. So if you use this approach, you need a way of transferring the statistics from the on-prem system to the cloud database for testing. But we will cover that later on today. And finally, don't do this in production. You might think, well, you've shown us two extremes. Either you bring all the data or none of the data. Why not go in between and do data subsetting? That is actually a very good question, and it does sound very appealing at first. But from our experience, data subsetting is really hard. You can use the Enterprise Manager's features in data masking and subsetting, but still with those tools, it is really hard to get in place. Because which data should you remove? Should you just remove some of the oldest data, or should you do it random? What makes sense in terms of your testing? What about referential integrity? Well, if you remove a row in a parent table, you could do a cascading delete to all the child tables. It's not very fast, but what about those, I would call them logical integrity? Something that makes sense to the application itself, but cannot be enforced with referential integrity. It might be that for some customers, you have to have some sort of static data in another table. How can you ensure that your subsetting will work on the complete full application picture? We think it's hard. But subsetting can still be an option because there might be some part of your application that you don't need. It could be, for instance, auditing or historical data, logging, or some sort of temporary data that is only needed for calculations. If you can exclude some of the table area, some of the table groups in your database, you can do that with Data Pump by using the exclude option and then specifying all the tables that you don't want. The problem with that approach is that when you then do the import, for instance, in this example, the costs table will be completely missing. If you try to connect an application to that database, it'll probably error out and say, whoa, I cannot continue here, a table is missing. A better approach is to exclude the table first and then do another data pump run where you include only the tables that you excluded in the first run, but then again you use the content equals metadata only to then export those tables that you want as empty tables. So it's a two-step operation. First, you include all the tables where you also want the rows. And in the second run, you take only the tables that you want created as empty tables. If you are using RMAN to restore or duplicate the database, you can also do subsetting in some scenarios. If the subsetting data is totally isolated in one table space, you can skip it when you do the restore or the duplicate. Those table spaces will be marked as offline table spaces, and you will get an error if you try to query a table that was in a table space that was skipped. So you shouldn't consider those tables as empty tables in your target database, and you might need to clean up in the data dictionary afterwards.
Thanks, Daniel. And we are on for our next challenge. Challenge number 4, setup. What does that mean? If you would like to test now, we would like to avoid also rebuilding our environment over and over again. So we need to think first how we can go backwards without rebuilding everything. And this is what we would like to show you here. Because all our tests need to be repeatable, and therefore we will use guaranteed restore points or a snapshot standby. So for a guaranteed restore point, I guess you're familiar with that technique. You set a GRP, then you test, and especially if a test is destructive, you would like to go backwards afterwards. And this is easily done with a flashback database to the GRP. So before test, on the left side of this table, you set the GRP with create restore point, whatever name, guarantee flashback database. Then you do your test or your upgrade. After done with that, you shut on immediate, startup mount, flashback to the restore point on the right side of the slide. Then you shut on immediate, and you go back to your source environment, especially if it's different environments, and then you startup mount and your alt database open reset logs. That's a simple technique. It's very fast, and it just works. Another technique would be using a snapshot standby. So in this case here, we build up a hybrid data guard setup. Our production database is still on-prem, and there's this great technical brief out there explaining how to easily build up a physical standby in the cloud while your source is still on-prem. This is quickly done, and once the standby is in place, we can convert it into a snapshot standby. Then automatically a guaranteed restore point will be set. You can test and destroy or whatever, and once you're done, you convert back into a physical standby. And the good thing with that technique is your logs still get shipped while you do that. And so once you convert back into your physical standby and several gigabytes or terabytes of logs have been sent over, before the database will be made available, it will sync all the log files. So you're always up to date. And this is very important. In some cases, you need always up-to-date data, and then the snapshot standby technique would be the best. And then on with Roy here.
Well, because we're talking mostly about performance testing here, it definitely means we should talk about statistics, because having accurate statistics is the best way to get good performance, and the statistics on your test system need to mimic your production system as closely as possible in order for your testing to be a good analog of production. So let's talk about first some high-level information about statistics, just some things to know. First is that there are multiple categories of statistics in the Oracle database. We might think mostly about table statistics and index statistics, the kind of things where you'd have how many rows are there in a table, how many unique values, and so on. The optimizer uses that information to help develop query plans, of course. It also can use system statistics. System statistics are there to calibrate your I/O subsystem, your CPU, and really characterize the hardware. Helps the optimizer make a trade-off between CPU-intensive types of retrieval, like, say, indexing, and I/O-intensive retrieval, such as a full table scan. There are also fixed object statistics and dictionary statistics, which can come into play, but those are much more of an issue for things like an upgrade or a data pump export than they are for most production workloads. So if we look at system statistics in particular, you're going to the cloud, doing your performance testing. Well, what if your system on premises doesn't actually mirror what we have in the cloud? That's a good reason to have your system statistics moved up to the cloud, because then the optimizer will be using that data from your production hardware to help inform its optimizer plans. So it sounds like a great idea to have this. And you might be thinking, well, should I be gathering these system statistics? I haven't really done that before. And most people don't gather system statistics. Because even though this sounds like a great idea, when you talk to the optimizer experts, and in this case, this is from Nigel Bayliss, the optimizer product manager, he will tell you that in most cases, you should use the defaults and don't gather system stats yourself. There is one case where we would recommend gathering system stats, and that's if you have a pure data warehouse workload on an Exadata system. That will really tilt the use of the I/O subsystem for your typical data warehousing query patterns. The way it accesses a long-running query, returns maybe a large data set instead of that individual, very quick OLTP type of access. But if your workload is mixed, if you have any OLTP in there, just use the defaults. That's going to be your best bet. So hopefully that demystifies system stats for you a little bit. Now that you understand the categories of statistics, we can talk about how to get the statistics from production up into the cloud and use them in your testing environment.
So system statistics are really important, but now we have to move them into our cloud environment. So let us transport the system statistics and maybe other statistics as well. The mechanism will be the same. You can transport statistics, all types of statistics in the database between different databases with dbms stats package. So you copy the statistics to and from a staging table. That's the idea. The staging table is like our parcel. We put the statistics in and we send it over, and then we unpack it afterwards in a destination database. And we can do this with schema stats, with table stats, with system stats, of course, and rarely database statistics, because that will include really everything. And same applies for dictionary and fixed object stats, which is also very rare. We have basically two use cases. In the first use case, this is the ideal or the best case. You restore a complete database. When you do that, you take all your stats with you. And especially those the database uses to build up histograms correctly in call usage dollar, those are in the database as well. Whereas when you build up a database with a data pump import, then you don't carry the call usage dollar statistics with you. In that case, it's recommended, in case you generate or gather new statistics, that you generate them with method opt-skew only, because otherwise the database won't be able to generate correct histograms. If you do full database export or subset or schema export, or if you do metadata only with no data at all, doesn't matter here. In all these cases, you have to be a bit more sensitive and we have to transport some statistics. And let us do that. So this is my source database and I have my user data and I have my data dictionary, and statistics are always in the data dictionary. So we need to grab them from here. And what we do is we create at first a staging table. So this is like our parcel box. And here I name it sys_stats staging stg. And once I have the staging table, I move now my system statistics in our case into that staging table. So it's export system stats, which doesn't do an export. It moves the data into the staging table. And then I call data pump. And with data pump, I export now this staging table in a simple dump file. Then I upload this dump file into my cloud environment. So here's my target database. I need to upload it into the object storage. And from the object storage, now I can import it into my target database in the cloud. So a simple import call with only this table. And once it's imported, if it's coming from a different version, which happens most of the time, and if you build scripts, it doesn't harm to call that anyway, upgrade the stats table, because then it needs to be brought into a current format. Otherwise, you receive a nice error message. Now the statistics table is upgraded. I can import it, which means I make them current now, and the call is import system stats. And now I overwrite the system statistics in my cloud database with the system statistics coming from my source database. And this is especially very important because usually you have different CPU specs, and so also different IO specs. And so you transport really that information over. And for our later stages, like SQL Performance Analyzer, it's really important that we do a little bit of a hide and seek game with the optimizer. We tell the optimizer, hey, your system is much slower or faster than it's real. So we get more real results. That's the idea here. And you may repeat this for schema statistics as well if necessary. Now let me show you a demo because I like that demo so much. We have shown this in the performance seminar as well. But the idea is really on source, we create schema and add some data. That's how we start. So here I create a user and I grant always DBA to that user. Makes life easier. User gets a table, transfer stats, a little bit of inserts, some rows. You see 100,000 rows, then an index. Okay, now let's gather and check the statistics. So I gather the statistics here with dbms stats, gather table stats. I check afterwards in all tab statistics, and you see number of rows, blocks, and so on, average row length. I also can check in all tab column stats, and here you see also the information about the histograms. So there's this column here with the histograms. All index stats give me a number of rows, how many level the index has. Okay. Now I would like to export these statistics. So I create again a staging table, and then exporting doesn't mean it calls the export. It moves my statistics into that staging table, directory, temp here. And let me do an XDP now with my directory for only that staging table. So it exports that staging table, 922 rows in the temp directory. I create now on the target not on the source anymore. You see the color changes. This is now my target database. I create a user again, grant DBA, create my table, empty table. And what I'm doing here is I bring in I gather table stats at first. And so when you see that, all tab statistics, there's number of rows 0. Of course, that's expected. This is just a check. All tab call stats, everything 0. There's no data, no activity, no nothing. And all in stats also, there's nothing in it. So number of rows 0. That makes a lot of sense, right? It was an empty table, no data in it. But now I import my statistics. So directory is again temp. And then let me call data pump import and import my staging table. And this staging table is all the statistics. Staging table is there. Now import the table stats. And you see there's an error. This is what I warned you of, Aura 20002. The stats are too old. So I have to call this upgrade stat table, and it doesn't harm if it's even same version. And then import the table stats. Now they're imported. Let us do the final check here. So now you see still no data in it, but I have exactly the stats I had before. Average row length 89, 215,000 rows, even though there's not a single row in it. And you see also the histogram statistics coming over. There are some new columns. They weren't there before, so they are 0 at this point. Okay. And let's check finally the index statistics. 215,000 rows, 2 levels, even though no data in it. And this is the concept. And this is why we want to show you that. This is how we can bring over our statistics.
Thanks, Mike. That was a good demo. When we talk about transporting statistics, there are a few things that you should know. You can safely export statistics to a staging table or import a staging table because the optimizer only considers statistics that are stored properly in the dictionary. The optimizer will never use statistics from a staging table. When you import statistics, they are marked as current in the data dictionary, which is the opposite of stale. So if the automatic statistics gathering job starts immediately after you have imported statistics, those statistics will not be refreshed because they are considered current. If you import statistics from an 11204 database into a 19C database, you will get an error saying you have to upgrade the stats table. There is a very simple procedure to do that, and afterwards you can complete the import. Also, if you're using incremental statistics for your partition tables, you have to specify that you want to include the synopsis information as well when you do the export. Highly recommended. After you have imported a stats table, you should gather statistics using dbms-stats.gather table stats on that table before you run the import schema stats or import table stats. When the stats table is created, it is, from a statistics point of view, an empty table. However, you are probably loading in thousands of rows into that table. So in order to give the optimizer some good statistics to work on afterwards, I highly recommend that you gather statistics on the stats table before you run the final import into the data dictionary. And then finally, if enabled, the imported statistics will be marked as pending statistics until you publish them. Okay, so now that you have migrated your database to OCI, you're ready to do some testing. Should you refresh those statistics? Well, if you upgrade from a lower version into 19C, the answer is it depends. If you are bringing all your data, this is something that you could consider. But if you're only bringing a subset of the data or only the structure, you should definitely not regather statistics once the database is in the cloud. We want to have statistics that represent the real data in your on-prem database. But if you have migrated the entire database, you can try to gather new statistics to see whether you can benefit from, for instance, some of the new histogram types. But there are some pitfalls when it comes to rephrasing the statistics. For instance, when the database is gathering statistics, it uses workload information to determine whether or not histograms are to be created on certain columns. So if you want to refresh the statistics in your test database, I would recommend first that you run a representative workload on that database before you gather statistics. Also, I would recommend that you disable the automatic statistics gathering job. It is normally a very good thing to have on your database, but in a test situation, we want to be in complete control of what happens to the database while we conduct the testing. Thus, disable the auto task. You can use the DBMS auto task admin functionality to disable the client. This is the automatic statistics gathering, and it's called Auto Optimizer Stats Collection. Simply disable it. You can also query the data dictionary to see if it is already disabled or if you want to get the status of it. Also, in 12.102, the database can now gather basic table statistics when a table is populated with data from a create table as select or insert as select operation. This is normally a very good thing. But again, in a test situation, we want to be in full control of what happens to the statistics in our database. If we are only bringing in a subset of the data, we don't want the database to gather new statistics when we load that subset into the database. But again, if you are bringing all of your data, it might not be of concern. If you want to disable that feature, you can either set an underscore parameter in the database, or if you're loading the data in some other manner, you can also use a hint to disable it. Okay, so we talked a lot about ensuring that the statistics are as we want them to be. So you might ask, should I log them? Well, you can log statistics to prevent them from changing. This can be a good thing in certain static environments or if you have highly volatile tables. It could also be that you want the database to use dynamic statistics. And I know that this is kind of a religious topic, so some of you might have a very good idea to when to use logging of statistics. There are procedures in the DBMS stats package that you can use to log the table statistics, but you can also do it at schema or partition level. And you should be aware that when you log table statistics, the underlying partition statistics, if it is a partition table, and index statistics gets logged as well. Some things to know about logging statistics. It causes cursor invalidation. In a test database, we probably don't care about that, but it's good to know if you eventually are tempted to run it on the production database, because cursor invalidation on a very active database can be a huge problem. If you're thinking, well, can I get some good statistics in my test database, put them into my source database and log them to achieve good plans, to achieve plan stability? You might be able to do that. But if that is your scope, you should use SQL Plan Management instead, and we will cover that later on today. If you run the Statistics Advisor in your test database and you have logged statistics, you will get an error or a warning saying this is something that you probably should reconsider. And finally, it's good to know that the logging information, the bit in the data dictionary that defines this is logged statistics, those information are not exported when you transport statistics. That was enough about statistics today.
Well, now that you've got your database in place with the statistics from your production system, it's time to bring a workload up to the cloud and use it with the testing tools that are available in the various cloud editions. And that means collecting information from your source production system so that you can use it to test the cloud environment, perform that analysis that you need to do. The easiest way to get a workload from the production system is to take a SQL tuning set. And this is a feature that is available in Enterprise Edition. without having to have any of the tuning pack, diagnostic pack, what have you. You can gather a SQL tuning set from production and get the information from your automatic workload repository or from the cursor cache. So what is a SQL tuning set? An SQL tuning set, as you can see here, gives you the information about a statement that will allow us to perform the performance analysis that we need to do and understand why the statement executed the way it did. So it includes not just the statement itself, the SQL ID, the SQL text, but the context in which it was executed. That's things like your parameter settings, your system characteristics. Then you have the statistics that were used by the optimizer, your object statistics, system stats, and so on. And then it also gives us the plans that were used as part of executing that statement. All of that is bundled up into a SQL tuning set. So that gives us the full package of information that we need to analyze performance. So how do we get this? Well, the first thing you do is you create the notion of this SQL tuning set. And when you execute this statement, what we're doing is we're just setting up a SQL tuning set that we can then insert things into. Then we actually have to get the information that we want inserted into the SQL tuning set. One of the ways you would do that is to get statements from your automatic workload repository, or AWR. And there are a couple of key elements to the code snippet that you have here. First is that with this select statement, what you can do is get all of the SQL tuning set information for every AWR snapshot in your entire AWR retention period. That would typically be a month or more of information all in one SQL tuning set. So that's pretty handy. Then you open a cursor to extract the information from those AWR snapshots into a format that the SQL tuning set will need. And then you run through that cursor, gathering the information from the AWR snapshots. That will give you a really nice package of all of the top SQL that was executed throughout your entire AWR retention history. But there are cases where you might want to also get information from the cursor cache, specifically cases where you have a high performance OLTP system where a lot of those statements may not actually make it into the top 50, say, top 50 SQLs that would show up in an AWR report. If you know that you have specific time periods for which knowing the performance is ultra critical, you can pull the cursor cache and it will grab the information about every cursor of currently executing statements while the polling is running. Do note that there is some overhead to doing this. It's kind of the Heisenberg uncertainty principle. The fact that you are trying to observe directly from the cursor cache is going to affect your system performance while you're doing it. So it's not something that you want to turn on 24/7. And once you have that, then you want to transport your SQL tuning set. And that's what we'll talk about next.
Thanks again, Roy. So since we collected now our workload statistics from AWR and from cursor cache, I'm the transport guy. So we need to bring over that information into our cloud instance. And this is what we're going to do here. So we transport now our SQL tuning sets. And we interact with SQL tuning sets and data pumps. So the idea is we pack again now the SQL tuning set into a staging table, not a statistics anymore as before. Then we export the staging table. You know that already. We upload it to the object storage, and then we import it into our test database in the cloud. That's the idea. So let's see how we do that. So at first, we pack our SQL tuning sets containing all the information from AWR and from cursor cache into a staging table on source. So at first we create a staging table, and then we say pack staging table top SQL set, which means please pack a SQL tuning set into a staging table. So I have to specify the SQL tuning set's name here, which is UPG_STS for SQL tuning set _1. Optionally, I can use also DBMS SQL Tune remap staging table SQL set to remap between different con IDs. That may be useful sometimes as well. It's a staging table, so let's export it with data pump, one table, you upgrade staging tab 1. That's it. Now that staging table has to be sent over to the cloud. Optionally, before we do that, If it's a lot of data, you can think of compressing it, but keep in mind that requires a compression license, or you simply use just zip whatever compression tool on the OS side, which doesn't require a license. Then I transfer it. Either SCP or rsync would work, or you could use also the OCI CLI, the OCI command line interface, which, as you can see in the code, allows you also to parallelize the upload. So in that case, we won't do this most likely, and parallelizing this into 4 different streams. But when you want to move over your database, then this parallel upload count could be very, very useful. If you want to allow somebody doing that without handing over your API keys, your connection keys to the cloud storage, then you can generate also a pre-authentication request and then allow somebody else to store the data into the object store without handing over your keys to that. Once data is there, we just import it into our target database. So the staging table is there in our target database after the import, and now we need to unpack it. So the best thing at Christmas is always unpacking the gifts, and we unpack our staging table with all SQL sets in there. So we use a wildcard, a placeholder, and you need replace true, and then staging table name, which is the known staging table name, and that's it. The good news here is we use SQL tuning sets, and you may wonder and say, oh, does this require a license? So SQL tuning sets can be accessed by way of database server APIs. That's how you think about it, and command line interfaces. The usage of any subprograms in the DBMS SQL set package to manage SQL tuning sets is part of Enterprise Edition. So there is no SQL tuning whatever license required for that. So all these subprograms, part of DBMS SQL Tune, to use these things, so SQL tuning sets are always part of Enterprise Edition. So you say, create staging table, load SQL set, select from cursor cache, capture cursor cache into SQL set directly, all these things, or also select workload repository are standard Enterprise Edition. No tuning pack license required on-prem. And this is why we want to use that and why we want to show you that. Because in the cloud deployments, that is all there. So we can easily use that without the need for the license on-prem. Even though we would want you to have that license, and I hope everybody has a diagnostic and tuning pack license. But still, you can work without that. And always capture workload data into SQL tuning sets, please.
Wunderbar. Let's attack the next challenge, which is comparison. Now that we have captured a lot of information and transferred into the cloud, let's see if we can compare some data and get some good insight. First, the objective is to compare workload data, and we will use AWR snapshots and the diff report to do that. So the idea is that we set a snapshot in our source database, we run a representative workload and do another snapshot. We then export that AWR database and import it into our cloud database, where we can then run the same workload and then compare the snapshots. You should be aware that due to the completely different nature of the source database and the target database or the test database in OCI, it might be that some of the findings from the AWR report doesn't make any sense at all. So the idea here is not to go into the very small details and chase seconds or milliseconds, but it's to get an overview, the bird's eye perspective, and see if there is something that really sticks out. The idea is that on the source database, you have run your representative workload, and you then use the script AWR extract to data pump the information out of the source database. You then, on the test database in OCI, use the AWR load command to get those AWR data into the data dictionary of our test database. And then we can use the script AWR DDRPI to compare the workload information. Normally, when you use the diff report, you use the script called AWR DDRPT. But there is a similar script called RPI in the end, which allows you to choose a different DB ID for the two sets of snapshots that you are comparing. So this is why you have to use the AWR DDRPI script, because most likely the DB ID of your database has changed in OCI. You then get a diff report, which shows the differences between the two sets of snapshots, one from on-prem and the other one from the test database in OCI. And again here, the idea is not to change the very small details, the very small knobs and commas, but it is to get an overview of the workload.
Thanks, Daniel. So AWR diff reports aren't the greatest thing here. Let's see if we can do something different, more useful with the SQL Performance Analyzer. So the idea is we find bad plans by simulating the SQL execution, and then we compare before and after. So with the SQL Performance Analyzer, which is part of all the cloud deployments, we built the analysis task, and we simulate the statements we captured either from Cursor Cache or from AWR, from prod. We compare the results, then we may remedy the issues and repeat our analysis. This is the idea here. So let's go for it. This is in my example 11204 database, and this is my SQL Tuning Sets production workload. So this is what I captured. And you know what all their statements and everything is in that production workload. Now I upgrade, I migrate, whatever I do, I'm a 19C. And with this information from the SQL tuning set, with the SQL statements, the schemas, the binds, and everything, we can now do a SPA test execution. It's like simulating in a sandbox. And in order to get good results, statements are simulated more than once, of course. So we have now before upgrade and after upgrade, or before migration and after migration. And we compare now on 6 different metrics. So elapsed time, CPU time, buffer gets, and discretes are the most important ones. And we compare, of course, also plans before, after. So this comparison is really important. And what we get here, we generate a regress report. So we see here just 2 statements. And you see the SQL trial 1, this is from production workload, what I captured. And SQL trial 2 is from my test execution, from my simulation. I get the net impact of each statement. And let's check a little bit closer that second statement, C set, set, set. So what do we have here? What information do I get? I click on the statement SQL ID. So I get a statement in clear text, and now we see all the execution statistics, the different metrics like elapsed time, parse time, CPU time, and so on. And we see compared before, after. Very helpful here is the arrows up or down, because that gives me a quick indication where I lose time. And I get also in the same report the plan before and the plan after. So this statement had a plan change, so I can compare now plans. And later on, we look forward what we could do now with this information that we have a plan change. But the cool thing with SQL Performance Analyzer, this is not a one-time shot. We can go forward now, and we continuously improve our environment. Because let's say I do whatever. Let's nail down a plan with SQL Plan Baseline. Let's create a SQL profile. Or let's change in Idora parameters. I can recompare over and over again. Just make sure you use useful names for your regress reports. So I implement a change now. Then I execute SPA again, I simulate again, and I get a new result. So I compare before, after. And we did this in the past for customers, for instance, just to find out what is the best setting for optimizer mode. And we have a lot of ideas here. So we could think of, hey, in Idora parameters, optimizer mode, what is best? All rows, first rows 10, first rows 100, or in some databases, I see this sometimes in older databases, you have optimizer index cost adjust set to a really weird value. Just not let the database do any full table scans. But modern I/O systems are so much better in reading full tables. Let's try let's change optimizer index cost adjust, or let us gather new statistics or new optimizer settings. Let's implement the changes with the new RU. DBMS Optim bundle allows us with a fixed control setting to implement and turn on now all the behavior changing optimizer parameters in a release update. Or let's try different histogram types or new synopsis. Not only the space consumption, but also how long does it take to gather them, and then evaluate if it does something good to our environments, if performance gets better and whatever, or try out specific patches. So you see, there's a lot of ideas we have. And the cool thing is, you check that in, and then you re-evaluate with another SPA run, and you check your regressed reports. And this is how you can optimize your system. And of course, also nail down plans. One thing we want to tell you here, because that is a new and easily overlooked feature of the SQL Performance Analyzer in 18C, you can check also for rows and result sets. So you get the number of rows and the results compared to each other, which is quite an interesting technique. You can try out a lot of useful things with that. And in order, if you think, oh, this sounds good, but where do I start now? We put on the block all our scripts. So how to capture from AWR, how to capture from cursor cache, how to use SPA runs for evaluate are based on CPU time, on buffer gets, on elapsed time. And you can easily change these procedures also for direct IO and whatever. And also the reports here just for the regressed reports, because we think it's the most helpful ones, but please feel free to grab them from the block. And now on with Roy here.
So as you can see, SQL Performance Analyzer is really great for delving into individual statements and query plan changes and being able to focus on only query plan regressions when you're looking at an entire workload. But when it comes to really characterizing workload performance, let's talk about another tool, database capture and replay, the other half of real application testing. Database replay can capture a workload and then replay it using the full concurrency or even different levels of concurrency on a destination system. And that destination system can differ in Oracle version, Oracle platform, and other characteristics. So it can be a really useful way to validate a migration, performance changes, any sort of tuning that you're doing. The way database replay works is that we start on our source system and we capture the workload directly by listening to the database calls that are being executed by the database. So we're kind of sitting between the client and the database and looking at the database calls. We capture that into what we call capture files. Now you have a target system where you want to perform testing. In this case, maybe it's a 19C test system in the cloud, and it may be even a pluggable database where your source database was a non-CDB. We bring the capture files up into our new environment and we pre-process them. That pre-processing is making them platform independent and allowing us to replay with differences in things like how many concurrent users there are, for example. Can be very helpful if you want to move to new hardware where you're assuming that you're going to have a higher workload in the future. Then we run through the replay and then we analyze it, giving you a nice report that gives you really useful and insightful information about how your workload will perform in this new environment. The replay report looks like this. It's a nice summary where it compares the capture side, the replay side, and we're looking at things such as the statistics like how much time did it take, the overall execution time. That's usually one of the things we want to look at. We see in this case, for example, it took an hour to capture, an hour and 49 seconds, so essentially the same amount to replay. That's great. We also see error divergence and data divergence. Are there any error messages that showed up during the capture that don't show up in the replay? Any that changed? Any new error messages from the replay that weren't there during the capture? And likewise, we will record instances of any DML that returns or modifies a different number of rows in the capture than it did during the replay. Now, all of this is happening at the workload level. And what we're looking at is the percentage of total calls in most cases that are different one or the other. Because around the margins, yes, there can always be some level of variability based on timing and other conditions. But getting this high-level report can give you some comfort, for example, that yes, our new hardware can actually handle the workload that we have before it. So a few facts about database replay. One, as I mentioned, it's platform independent. It's a really great tool for moving cross-platform, especially as many customers are going from the, I'd say, proprietary Unixes, your Solaris, AIX, HPUX, over to Linux. Often that platform change can introduce differences, and you want to make sure that Linux is going to perform well for you. And that includes being rack compliant, because many of those legacy Unix vendor machines are big, massive multi SMP boxes where you might be going to, say, a 4-node cluster of commodity Linux blades, and you want to see, well, how is this going to affect my workload? Am I going to run into wait events? What kind of concurrency can I handle? How many nodes do I need in my rack cluster to handle that workload? We can also capture and replay on a PDB by PDB basis. And this goes both ways. We can do it on an individual PDB. So if you have a consolidated environment, you want to just see how that one pluggable database will work when you upgrade to 19C, you could do that. But you can also perform a consolidated replay. You have multiple source databases that you want to put into the same CDB. You can replay them all together and see whether they will coexist nicely with each other, or whether you're going to run into resource issues or contention and so on. And finally, you can capture and replay, of course, across different database releases. The kind of boxes and arrows slide I showed had 11.204 replaying on 19C. So it's a terrific way to validate your upgraded database. Finally, we do have scripts that you can download, and it makes it easier to do all of this. Whether it's starting your capture, analyzing your replay, scripts are there available in the link that you can get in the downloaded slides. But there are some considerations. Let's be honest about this. Workload capture does have some restrictions, especially about things like, say, XA transactions. When you have these distributed transactions like that, it can be difficult, or there may be limitations where you can't use it. Also, it's not really suitable if you have a database with lots of external dependencies. If you picture taking a copy of a database that has DB links or external tables or accesses things over the network, when you're doing that replay, we are really replaying those transactions. So you don't necessarily want to be replaying if you've got a DB link that points to the same database as production. You wouldn't want to be doing any inserts over that DB link from your test system. Simple as that. So be aware of your external dependencies. It's also a good idea to restart the database before you start capturing, and then maybe even give it a little warm-up period to make sure that the various memory pools and caches are populated, because that way you won't have any in-flight transactions. So you want to give it that warm-up time then to make sure that the statistics are reasonably accurate to what your production system would be. So it's kind of a creative tension there between making sure you don't have anything that's kind of halfway through when you start your capture, but also that the characteristics of the system will accurately reflect production. And then finally, it does work best when you start with a dedicated SCN. And we mentioned this when migrating with Data Pump. If you can start your capture at the very same SCN that you start your Data Pump export, then the database on which you are replaying will be identical to the database on which you're capturing. And that's really what you want. So make sure you use that dedicated SCN wherever possible.
Okay, now that we have found those misbehaving queries, let's see what we can do about them. Because it's tuning time. We can use the SQL Tuning Advisor to analyze a query and come up with recommendations that can make it run faster. Some of the things that can come out of the SQL Tuning Advisor is, for instance, to gather optimized statistics or gather them in a different way, for instance, using extended statistics. It could also be that you need to create indexes, but a SQL Tuning Advisor looks at one specific query only. So even though it might recommend creating an index, you need a more holistic view to determine whether or not that's really a good idea. It can also come up with recommendations on creating SQL profiles, and let's dig a little deeper into the SQL profiles. Like the Tuning Advisor, SQL profiles are part of the tuning pack. So if you create a SQL profile and you want to transfer that back into your on-prem source system, you have to ensure that you have the tuning pack available there as well. If you don't have that, you can still use the Tuning Advisor to create a profile. You can then run your workload, and with that profile, produce a good plan and put that good plan into a SQL baseline. And you can then transfer the baseline back to your on-prem system. So you can still use Tuning Advisor and SQL profiles, even if you don't have tuning pack on your source database. The Tuning Advisor works by creating a set of extra statistics that the optimizer can use to select a good plan. A profile affects only one query, and you can selectively enable and disable the query, which makes it useful for testing. It's completely transparent to the application. The application won't know if there is a SQL profile. It will only know that the query completed fast because there was a good plan for it. Profiles are persistent, they survive database restarts, and they are transportable, so you can take them from your test database in OCI back to your on-prem database. But remember, profiles are part of the tuning pack, so you have to have that on the source database if you want to transfer them. And one of the really good things about SQL Profile is that they can work on statements that use literals as well, because they can use the force match option, which will allow a SQL Profile to be reused on multiple statements that are using literals. When you need to test your SQL Profile, it is also very easy. You can assign a SQL Profile to work only in a specific category. You can then use an alter session command to set the SQL tune category to that where you have selectively enabled that profile. You can then run your workload to see whether it behaves as expected. If it behaves as expected and you want it to apply to all sessions, you can change the category into default, and now it'll work for everyone. Now that we have identified some good solutions for those misbehaving queries, it is time to move on.
So thanks, Daniel. Next step will be SQL Plan Management, how to manage our plans, how to fix them. So we can use SQL Plan Management to accept plans, enable them, or fix them. And we can change the status between each other with the procedure DBMS SPM alter SQL plan baseline. We can also prevent plans from getting purged with the auto purge property. That is quite helpful if you have plans which just come in very rarely and you want to prevent them from getting purged. Now, what we could do is we could load all plans from the SQL set. This is our SQL tuning set with all the plans in there. So we could simply use DBMS SPM load plans from SQL set and just move all of them. Here it's just one plan, and just move that plan C, and it will be automatically accepted as soon as we call this procedure. And we can do this with 100 or 1,000 or 10,000 plans if we need to. Still, we are not such great friends of this procedure, even though we could easily have a test environment. You could give it a trial. It's easy. This is why we have the test environment. What if you have literals? You know that story already, many distinct statements, and cursor sharing force does not work with SQL Plan Management. So if your application uses a lot of literals, then SQL profiles are the much better solution, because you can accept a SQL profile with false matching true, whereas if you don't use SQL profiles, the only escape you have is cursor sharing force, which is not a great idea if you have binds. The optimal solution, of course, would be convince your application people to write code which use only bind variables. But I don't tell you news here, I guess. So what would be our use cases? So we have now plans from production. We capture them. And in our test environment, we have plans from our tuning efforts. Now, they are all in SQL tuning sets. And this is our production. So what we do is we load these plans here from SQL Tuning Set into that SQL Plan baseline of our production database. And if you need to, you can even filter. If you say, I don't want all of them, so you filter here on SQL ID, and please always add the plan hash value, because both of us just make a unique combination. And then load plans from SQL Set and use as a basic filter that filter parameter you defined before. That can also fix the plans, by the way.
Now that we have all this great information about performance tuning that we've acquired in our test system, we want to make use of it on premises. And that means instituting this virtuous cycle of bringing information from production up to test, but then bringing the knowledge that we gained in testing back on premises. And we'll start with those SQL Plan baselines that are used to stabilize performance after an upgrade, for example. Now, SQL Plan baselines are stored in the data dictionary, and they have a very specific format there. So in order to transfer them from one database to another, we use what's called a staging table. We give it an intermediate format that can be packed from one side and then unpacked from another. So the first thing we do, similar to creating that SQL tuning set, is to create a staging table from your baseline. Then you select the baselines that you want to transfer. In this case, we're saying enabled equals yes, because those are the ones that we've determined are accepted and good baselines. We don't want to take query plans that are somehow in say, the query plan history, but that haven't been verified yet. We also bring over any of the ones that we fixed, the ones that we said we don't want a new plan for this particular query. We're going to use the plan that's been fixed in the baseline. Then we can just take that single table, it is just, after all, one table, and we can bring it over into our production system, maybe using a DB link. It's very convenient to do that because it is just, after all, one single table. You could optionally export to a dump file, and then you'd have to copy the dump file back on premises and do the import as another operation. So you could do one operation, network import, or the 3 export, copy, and import to get the dump file into your production system. Once that staging table is in production, then you load the plans from that staging table into your query plan baseline, and now you have a populated SQL Plan Management baseline in your production environment. Do note that this is only available for Enterprise Edition for on-premises databases. You can't do this if you have SE2. So now that we've got our SQL Plan baselines there, you might be wondering, but what about all that stuff we might have done with the SQL Tuning Advisor? What about the profiles? Because those are not part of the SQL Plan baselines. And I'll let Daniel fill you in on that.
Thanks, Roy. Let me also mention that you can transport SQL profiles. SQL profiles are stored inside a data dictionary in a format that you really can't transfer. So first, you have to convert the SQL profiles into a transportable format. The first thing you do is to create a staging table. You then select which SQL profiles that you want to transfer. In the example here, I'm simply taking all the SQL profiles that belong to the default category. But if you want, you can go into the details and more selectively filter out the SQL profiles that you want to transport. The SQL profiles are now stored in a regular heap table, and I can use data pump to transport that table. For simplicity, I'm just using data pump here to transfer the table over a database link. But if that is not an option to you, you can just as well export to a dump file and then back into the production database. Finally, you can then load the SQL profiles from the staging table and into the data dictionary where they can be used by the optimizer. But before you do that, you have to be aware that SQL profiles are part of the tuning pack. So if you have created some profiles in your test database in OCI, before you load them into your production database, you have to ensure that you have the tuning pack licensed there as well. Otherwise, you cannot transfer the profiles. That's it. By preparing yourself and by using the test resources in OCI, you can now sit back and relax and enjoy some good music. Good luck.
So that's it for today's webinar. We hope you enjoyed this session and that it will motivate you to start using the cloud for your performance testing.
Next time we will... Wait a minute. It's summertime. I guess all of us deserve some time off during the summer to relax. But...
And we'll be back soon with more upgrade best practices in autumn. October next time. Until then, take care, stay safe, relax enough, enjoy the summer, and see you soon again. Thanks and bye.